Hello, hi everyone, welcome back to the channel. So today in this video lecture, we're going to be solving this problem, same tree. So in this problem, we're given two binary trees, the roots of two binary trees P and Q. These represent the root nodes of the binary trees. We need to write a function to check if they are the same or not. Basically, the binary trees are same or not. So when do we consider two binary trees to be the same? If they are structurally identical and the nodes have the same value. Like in this case, these two trees given in the example number 1 are identical. Because they are structurally identical, both of them have 3 nodes and the values at those nodes matches. The root node of both of these trees has a value of 1. The left node for the left subtree contains 2. Same goes for right subtree. And the right node of the left subtree contains 3. Also, the right node of the right subtree also contains 3. So they are identical. So what do we have to do in this problem is to return true or false depending upon whether these trees are identical or not, right? So let's see how we're gonna solve this problem. So basically the problem is simple. If you're given two trees, so let's take two trees. So let's take a tree 1, let's say we have 2, we have 3 here, then we have 4, like this, and we have a similar tree 1, 2, 3, we have 4, like this. So we need to check if they are identical or not. So how we're going to do is we basically check, we start from the root node. This is the root node. We compare the values here, they are same, fine. We move to the left subtree of the left tree, this one. We also move to the left child for the right subtree as well, which is node number 2. So here, so now we are standing at this point and we are standing at this point. So let's say P represent the pointer, which basically points to the which points to the root node of this left subtree, and Q is the pointer which points to the root node of the right subtree. So now the P is standing at this node and Q is standing at this node. So let's match the values. The values are same. You can see that 2 matches with the 2. We again move to the left child. So we move here. Also we move here. So we compare the values. So the P comes here and the Q comes here. Let's compare the values again. They are 4. So let's move to the further. Let's move to the left one more step. We can see that this node, that is node which contains 4, do not have any left child. Same goes for this node as well. That means till this point they are identical. So we return to the calling node, which is node number 2, and here we return again. We can see that both of these two nodes do not have right child. We again move back. We move back here. Now here we can see that we have the right child for this node. Same goes for this. We have the right child for this tree as well. So we move to the right child. Okay, so we are here. The P is here, Q is here. Let's check the values again. We have 3 here, we have 3 here. Do we have a left child for 3? No, we do not have a left child for this 3. Same goes for this 3 as well. We do not have a left child. We also do not have the right child. This node also do not have the right child. So that means these trees are identical, right? So what do we have to do is we basically create a function. Let's see, is same tree function which is given in there, and this takes in these pointers P and pointer Q, and what this returns is true or false depending upon the trees whether they are identical or not, right? So initially in this function we have P and Q. What we're going to do is we're going to check if these nodes P and Q are null. So this is the base case when we arrive at a node which is, let's say, left child of this node 4 and left child of this node 4. We can see that we do not have any left child. So in that case, P is null and Q is null. So in that case, we return true. That means till this, that means we have matched the subtree of node number 4 for the left subtree and the subtree of node number 4 for the right subtree. So that is the base case. Otherwise, we have to check for any node on which we are standing. So let's say we are standing here initially at this point. We need to call the same function is same to recursively for the right child, which is node number 2, and the right child of node number q, which is the left child of node number 2 of node q, right? So left child of node p and left child of node q. Fine. So we'll call the same function recursively for the left child and for the right child. If both of the functions returns true, that means the left subtree for p for this tree and the left subtree for this node for this tree, as well as the right subtree of this tree and the right subtree of this tree matches with each other. Fine. So if they match and this node also matches, p, the value at p matches with the value at q, that means the trees are identical, and this holds true for all the nodes of the tree. So for every node, all we have to do is to recursively check whether the left subtree of that node and the left subtree of the same node in the right tree in this tree pointed by this pointer q are identical, and the right subtrees of both of these trees are also same, or both of these nodes are also same. So we have to check for 3 conditions. For any node, we need to check if their values are identical. So values of the nodes are identical. Fine. The second thing is the left subtrees for both of the nodes must be identical. That is left subtrees. And the third thing is we need to check if the right subtrees are identical. So if these 3 conditions holds true, that means the trees rooted at the nodes p and q are identical. Fine. So that's the thing. So let's jump to the code implementation part. So here we can see that all we have to check is the same. So let's check for the right subtree. Let's check for the left subtree. Left subtree for node number p and left subtree for node number q. Q left. If it returns false, then that means the left subtrees of these 2 nodes are not identical. Or also check the condition if this is same tree, same function is same tree for right and q right. If it is false, then we're going to return false from here. Otherwise, return true. Also here, initially check if p is same as q. In that case, if p is null and q is null, then we're going to return true. Why? Because this is the base condition. When we, let's say here for this case, let's say 4, we recursively call the same function for its left child and we pass null, okay, and also we recursively call the same function for the left child of this node, which is also null. So both of these subtrees are matching. Why? Because both of them do not have any node, right? So that's why we have to return true for this case. Fine. So other base cases, if let's say one of the child is null, maybe there is a case that p is null and q is not null. This may be the case, or there can be a case that p is not null and q is null, right? Or there can be a case that the values at these nodes q value is not equal to the value for the right subtree. If it is the case, then we're going to return false. So I hope I covered all of the test edge cases, the base cases. Okay, it's not capital Q, it's small q. So I hope you got the idea. Let's try to submit it. Got me a wrong answer. It's not null. Q is null. Okay, it's or. If one of them returns for, if one of these two conditions is true, then we're going to return false. Why? Because we can see that if the left subtree for the left tree and the left subtree for the right tree are not the same, then we return false, or the right subtree of the left tree or the right subtree of the right tree are not same, then we return are not same, then we return false. Fine. So okay, so that's all for this was a recursive approach, although there are other approaches which we'll discuss in other videos. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel, and we'll see you soon in my next video. Till then, take care. Bye bye.